Hello, Pafauzi and friends. Today we are going to explain to you our basic fluid mechanic project about our Jatigede Reservoir analysis. So this project was made by me, Shanwirya Mulyo.
Me, Alberto Hans.
Me, Nabil Fatih Ramadan.
And me, Ana Maria Phoebe.
So first we will start about a brief history about the Jatigede Reservoir or dam. So the Jatigede Reservoir is a large artificial lake located in West Java, specifically in the Sumedang Regency. It was completed in 2015 but only started service in 2019. It has been successful in preventing flooding, providing irrigation water for agriculture, and also generates electricity through the hydroelectric power plant, obviously. It has provided a lot of benefits to the local communities around the region.
Okay, so for a brief geographical description of the Jatigede Reservoir, it is located in the West Java province, specifically in the Cimanuk River Basin, and it's southbound of Sumedang and Majalengka regencies. The surrounding landscape of this reservoir is dominated by lush greenery, and most of the terrain there is hilly with several small mountains surrounding the area. Okay, next. And this is a small map of how Jatigede looks from the top, and as you can see, it is southbound of the Java Sea.
So here's the data and schematics of the pressure analysis of this dam. In this part of the dam, we analyzed two spots, which is in the radial gates and also on the dam wall. Firstly, this radial gate has the dimension of 13 meters by 14.5, and its elevation is given in the data calculation in the next slide. Next, it's the pressure on the dam wall.
So for the pressure on the dam wall, the dimension is 12 by 110 by 1,715 meters. And the calculation will be talked about in the next slide.
For the calculations on the force of the radial gates, firstly, we have to find out about the hydrostatic pressure that is exerted by the water to the radial gates itself. We have here some data, and assuming that density of water here is 998.8 and the gravity is 9.81, we calculate for the hydrostatic pressure, which is rho GH, and the H we use is the height of the weir peak, and that's like the elevation. And also by calculating the hydrostatic pressure we obtain, it's about 2.42 megapascal. And to calculate the force acting on the radial gates, we also have to calculate the pressure by the area times half. And the area itself, it's total area, which is the height times the wideness of the radial gates times the number of gates itself. And we obtain here that the force is 0.9124 giganewtons.
For the calculation on the dam, we need to first find the pressure that the dam holds. So by calculation, the dam holds around 15.2 gigapascal. And then next we use the hydrostatic force formula to find the force, which is half times the water density times the gravity times the height and then times the area. So first we need to search for the area. We get that the area value is 188,160 meters square. Then we search for the force that is held by the dam, and by my calculation we get that the value is around 1,432.54 giganewtons.
Membeli dam apa?
Okay, so from our data that we have obtained, we have made some analysis and conclusions, which is the first one. The total force that the water can exert to the radial gates is 0.99124 giganewtons, while the force that is held by the dam in total is 1432.54 giganewtons. And number two is that the Jatigede Dam uses concrete as its base material for the walls, since that concrete has high compressive strength and is able to resist big forces from water, wind, and other environmental forces. And last, it is also durable for long-term structures.
Also, another analysis that we have concluded is that the density of water, which is the fluid working here, the higher the hydrostatic pressure is also the denser the fluid. So fluid density may change due to its salinity and temperature. Fluids with higher salinity will have a greater mass, hence will make the fluid more dense. On the other hand, if the fluid is having a higher temperature, a water fluid here, the more space it will take up, meaning that it will be less dense. Depth of fluid also affects the hydrostatic pressure. So the higher the depth of fluid, the higher the pressure. This is because the weight of the fluid above increases, therefore increasing the pressure. Acceleration due to gravity, the greater the acceleration due to gravity, the higher the pressure. And those are some of the factors that we have concluded which might affect the hydrostatic pressure. So that's it for this presentation. We have learned that with the laws of physics and fluid mechanics, we've learned that hydrostatic pressure is able to create not only irrigation but also clean energy for the world to use. Thank you guys for listening. Thank you, Mr. Tubagus. Bye-bye.